The air around us contain a lot of suspended particulate matter or PM. Now, numerous studies have shown that exposure to ambient PM is directly linked to an increased risk in human mortality and morbidity rate. So, because of this, regulatory bodies worldwide generally measure the bulk mass concentration of PM to predict the health risk associated with PM exposure. Now, the question is this metric adequate? So these air particles are made up of different chemical components, and this composition of PM vary based on the location. For example, the particles next to an expressway would have a lot of silica, dust, diesel exhaust particles, and other metallic species which are generally emitted during traffic movement. In contrast, the air particles next to a forest fire would have a lot of organic species in them. So, because of this varying chemical composition of PM, researchers today are working on developing new health metrics which takes into account both mass concentration and chemical composition of PM. And one such promising alternate health metric is measuring the oxidative potential or OP of ambient PM. OP is the ability of inhaled air particles to induce oxidative stress, which is assumed to be the underlying mechanism by which PM causes various adverse health effects. Now, for my PhD research, I designed and developed a new instrument which measures the ambient particle OP in real time. So what I do is I take my instrument and I set it up at different locations and measure the real-time OP. Then I couple this real-time OP data with conventionally used mass concentration and chemical composition data. Then using some mathematical model, I determine the source contribution of OP. So that means I can determine what are the PM emission sources driving the OP at a particular location. An example I can give is at a particular site, I found that one industry contributed less than 5% of the total PM mass at that location, but that same industry accounted for more than 20% of OP. So, what this suggests is that the chemical composition of PM is very important in determining the overall health risk associated with PM exposure. So based on these promising results, I propose using OP in future health exposure studies to determine the relationship between PM exposure and adverse health effects at different geographical locations all over the world.